All right, today we are going on a proper scientific quest. Seriously, we're going to dive headfirst into this really fascinating, kind of mind-bending PhD thesis because it's on a search for something that could literally change everything, a single mathematical formula for intelligence itself. And I mean, just let that sink in for a second. We're not talking about some algorithm that's good at playing chess or, telling cats from dogs. We're talking about a universal equation, a formula for the very essence of what it means to be smart. Yeah, that's the holy grail we're on the hunt for today. Okay, so right out of the gate, our quest hits a massive roadblock. See, before you can even think about writing a formula for intelligence, you've got to agree on what intelligence actually is. And let me tell you, that turns out to be a surprisingly messy, complicated problem. It's just total chaos, really. You've got psychologists, you've got AI researchers, and they've come up with more than 70 different definitions of intelligence. I mean, is it about learning from experience? Is it about reasoning, solving problems, adapting to new situations? The list just goes on and on and on, and pretty much nobody agrees. But this paper, the one we're digging into, it just cuts right through all that noise with this beautifully simple definition. For now, let's just forget about all the abstract stuff. Let's just define intelligence as this: an agent's ability to achieve goals in a wide range of environments. That's it. It's simple, it's powerful, and most importantly, it's something we can actually build on. Okay, so if that's our definition, achieving goals in any environment, then the big question is, how do you actually do that? Well, the secret, the key insight, turns out to be prediction. You've got to be able to predict what's going to happen next. And to do that, you need this kind of magic tool, a philosophical idea that's been kicking around for centuries. And that tool is Occam's razor. You've probably heard of it. The basic idea is just so simple and elegant. When you're faced with a bunch of different explanations for something, the simplest one is usually the best bet, right? Like if I show you a sequence of numbers, 2, 4, 6, 8, what do you think comes next? It's 10, obviously. You don't assume it's some crazy complicated formula that just happens to fit those first 4 numbers. You go with the simplest pattern. So, back in the 1960s, this brilliant researcher named Ray Solomanoff took this philosophical idea and turned it into pure math. He created something called Solomanoff induction, which is, well, it's basically Occam's razor on steroids. It's this theoretical master predictor. It takes every possible simple explanation for what it's seeing and mashes them all together to make the absolute best guess about what's coming next. People have called it a grand unified theory of learning from data. So yeah, it's a huge deal. But there was one big problem. See, Solomanoff's system was the perfect observer, a perfect predictor. It could, in theory, watch the stock market and predict it flawlessly. But it couldn't play the market. It couldn't do anything. It was totally passive. And if we go back to our definition, intelligence is about achieving goals, well then just predicting things is only half the puzzle, right? To be truly intelligent, you have to be able to act. And this is where our story gets really, really exciting. Fast forward to the late 1990s. A researcher named Marcus Hutter has this incredible breakthrough. He figures out how to take Solomanoff's perfect but passive predictor and turn it into an active, goal-seeking agent. What he did was he combined that universal prediction engine with something called decision theory, which is just a fancy way of saying the mathematics of making the smartest possible choice. This was it. This was the final piece of the puzzle. It was like taking the world's most powerful brain and finally giving it hands to interact with the world. The result of this combination was an agent named AIXE, and here's the gist of how it works in this constant loop. Step 1, it observes the world around it and gets some kind of reward. You can think of it like points in a game. Step 2, and this is the crazy part, it uses that powerful prediction ability to consider every single possible explanation for everything it's ever seen, and it uses that to predict all possible futures. And then, step 3, it looks at all those possible futures and chooses the one single action that it calculates will get it the most reward, the most points down the line. Observe, predict, act, over and over again. And there you have it. AIXI. It's a mathematically provable, optimally intelligent, general-purpose agent. It is, at least in theory, the formula for superintelligence that we set out to find. So, quest complete, right? Well, not quite. Because just like in any good adventure story, there's a twist. A dramatic one. Right when we think we found the treasure, we discover there's a catch. And oh man, it is a really big catch. So we've got this perfect formula for intelligence. But yeah, there's just one problem. Okay, here's the catch. AIXE is completely, fundamentally incomputable. You remember that part where it considers all possible explanations for everything it's ever seen? Well, to do that, you would need a computer with literally infinite processing power and infinite memory. It just can't be done. So while the AI we have today is specialized and runs on actual hardware, AIXE is this perfect, universal, optimal thing that exists only as a mathematical ghost. It's the perfect blueprint for a machine that we can never, ever actually build. So you're probably thinking, okay, so what, right? Why did we just go on this whole quest to find a formula for something that's impossible to build? If we can't make it, why does it even matter? Well, it turns out that having a perfect, even an impossible blueprint is actually incredibly valuable. The whole point of AIXI isn't to actually build it. Its value is in being a North Star for AI research. It's a theoretical benchmark. It shows us the absolute peak, the ultimate potential of what intelligence could be. So when researchers are building the AI we actually use, they can look at this perfect model and better understand the compromises and the trade-offs they're making. It guides the entire field by pointing to the ultimate destination, even if we know we can never quite get there. And this really brings us to the huge implications of this whole quest, because the destination that a theory like AIXI points to, well, it's something people have been thinking about for a long, long time. The idea of creating a machine that's smarter than us. That would change everything. As the statistician I.J. Good famously said back in 1965, the first truly ultra-intelligent machine would be the last invention humanity ever needs to make. So let's end on this thought. We might not ever build AICI itself, but the systems we are building, piece by piece, are trying to get closer and closer to its power. This whole quest for a perfect formula, it's not just some abstract math problem. It gives us a real glimpse of where this road could ultimately lead, which leaves us with a pretty big question to think about, right? If this is the blueprint for superintelligence, what kind of future are we actually building with it?